Hello everyone, welcome to the session on deep learning series. We'll continue with the activation functions. So this is sort of an aggregation of each activation function which was discussed previously along with the other commonly used activation functions. The first one is basically your identity function, which is, I think this is straightforward, where you just take f of x is equal to x and derivative with 1. Next is basically a step function. Step function basically is for values of x lesser than 0, the value is 0, and the value of x greater than 0, the value is 1. Correct. Next is your logistic, or you can say this is your sigmoid function. This is basically a formula 1 by 1 plus e power of minus x. Derivative of that is, this is the particular derivative of your sigmoid. Next is your tan h function, a tangential hyperbolic function. This is that particular formula 2 by 1 plus e power minus 2x, and this is the derivative of it. So for people who are not sure, or who are not sure on the derivative or have some doubts on derivative, you can check the session in linear regression where derivative was explained, how to calculate derivatives was explained in detail. Next, this is arctan function. This is the formula for arctan function, and this is the derivative. Next is your ReLU, or rectified linear unit. This is a particular formula for ReLU, and this is the derivative of it. Next is your parametric ReLU. This is that particular formula. When the value of when the input is less than 0, this is alpha x, or if it is greater than 0, it's only x. Next, you have few other activation functions called as, one is your ELU. ELU is your exponential linear unit. This is nothing but your alpha into e power minus x. So previously you had only x, right? Over here what is happening is you're just adding alpha into, you're basically adding an exponential term over there, right? That is your ELU. This is the derivative. Next, something is called as soft plus. Not to confuse with soft max. Soft max is again one more this thing. So that's basically not an activation function. So that's basically at the end where you finally use it to get your output probabilities whenever you're trying to use a multi-class classification example, right? So this is soft plus. So just to again sort of make sure you're following this properly, because activation functions, I think at least the concept of this, right? So this is actually very important. That's why I think so much time is actually spent over here. This is your identity, right? This is your binary. Then this is your logistic, right? The other one is your tan h. This one is your ReLU, and either leaky ReLU or randomized ReLU, and this is your ELU, right? Next, I think the last two is basically your soft plus and arctan. This is your soft plus, log of 1 plus e. Log of 1 plus e is basically your soft plus, and the other one you have is your log of 1 plus e power x, log e to the power of 1 plus e power x. Next, this is your arctan. So these are commonly used activation functions, their derivatives, and their how does a function look. So the next sort of important topic, you can say something is called as, I think this more like term. So one more important term, something is called as epoch. I think whenever you at least sort of look online or look at any books for in general any deep learning model, right, you would generally come across few terms. One of them is mainly epoch. Then there's something that's called as batch size. Then there's something that's called as number of iterations. So these three terms you would actually come across a lot. So it is actually very important to actually understand what does it mean, right? Epoch is nothing but one epoch is when the entire data set, right? So when an entire data set is passed through the network, one forward pass and one backward pass. So when the entire data set is basically passed through the network, one forward, one backward, that basically constitutes an epoch, right? So I think let's take an example, right? Suppose you have 2000 samples, right? In this, your batch size is 500. Okay, so batch size is nothing but number of training examples present in a single batch. Okay, so if your batch size is 500, the number of batches are nothing but 4, right? Because you need 4 batches to complete 2000 samples, because 2000 your samples, total samples, correct? Iterations are nothing but number of batches needed to complete one epoch. Iterations and batch size. So you basically need 4 iterations to complete one complete epoch, right? So I think the next question would be how many epochs do you need, right? So one epoch is when a data set is completely one forward, one backward, right? The complete data set, one forward, one backward, is basically one epoch, correct? And coming to the question of how many epochs you would need, I think again I would again sort of go back to the linear regression example, right? Over there as well, gradient descent, right? We initially, if you can remember in the code, right, so we did sort of tell how many iterations would it be required, but usually that also would be done automatically. So it's basically an iterative process. I think this particular epoch and that gradient descent is sort of an iterative process, right? So you would need to know when to stop, right? One of the easiest ways to determine when to stop is basically at least in linear regression, this thing in the gradient descent, the calculation linear regression, your derivative should be very close to 0 or almost 0, right? I think over here as well. So whenever the number of epochs, right? So whenever the model converges, so whenever there's a convergence which is happening, or whenever there's a error stabilizes, again, so all of these concepts, right, would you have your bias and variance trade-off, right? You see the curve, training curve and the testing curve. It's from there only you can determine when is optimal epoch, right? So all of these have some sort of you can say dependency on the previous machine learning topics. So it's more, I think I would say more or less an extension of that. So it would be important. I think it's better to proceed from here on, at least only if the previous topics are sort of understood. Right. So you have your epoch. So you have your epoch. Then you have batch size. Batch size is the number of training examples. I think if you remember this, actually, with respect to, if you remember this, say from your with respect to examples, I think it would be easier to remember. Say you have 2000 samples, so your batch size is 500. You basically need 4 iterations to complete one epoch. So batch size and number of batches are different things, right? So batch size is number of training samples present in a single batch. Number of batches is, you can think of it as number of iterations. How many batches are required to complete one epoch, right? So these are sort of the fundamentals which you would need. I think in the next few sessions we'll actually look at an actual example. We'll basically walk through a neural network with an actual example. We'll give inputs, calculate the forward pass, calculate the backward pass. I think that should make things clear from there on. Okay then, thank you.